Yeah. Yeah. Good evening, all. So myself, Vijay, I hold like 15 plus years of experience, right? Which includes nearly 8 plus years of experience in big data environment like Hadoop and Spark. So as part of today's demo, just I'm going to cover the following topics. But before I start, can anyone please confirm whether my voice is clear, whether the screen is visible or not, right? Yes.
Yes, sir.
Yes, sir.
We can able to hear and I can able to see.
So, okay. So first, what is Apache Spark? Why PySpark? Need for PySpark. So most of them have got the query, right? Yes. Why we need to go with PySpark, Spark with Python implementation or Spark with Scala implementation, right? Like, so whenever I say like Spark versus PySpark, so Spark means by default it uses Scala language, and PySpark like Spark with Python implementation. Spark and PySpark, right? Spark with Scala. Otherwise, like you can say like Spark Python and Scala, right? Yes. PySpark features a real-time usage of PySpark. Yes. PySpark job market, right? Yes. Okay. So what is Apache Spark? Why PySpark? Need for PySpark, Spark Python versus Scala, and PySpark features, real-time usage of PySpark, and PySpark job market, right? Yes. So what is Apache Spark? Apache Spark, right? I can say it is a open source distributed cluster computing, right? Apache Spark is a open source distributed cluster computing framework introduced by Apache Software Foundation. Open source distributed parallel processed cluster computing framework which was introduced by Apache Software Foundation. So I can say it is a Apache Spark. This Apache Spark is a general engine for big data analysis, right? It is a general engine for big data analysis, processing, and computation, right? So this mainly used for, right, for data analysis, big data analysis, right? Processing and computation. So, okay, more on this I'll be discussing that, but why PySpark? Why PySpark? Okay, PySpark, I can say it's a Python API to use Spark. Python API to use Spark. Spark, I was saying that it's open source cluster computing, which is used for big data solution. So I can say PySpark is a lightning fast technology, which is designed for fast computation. PySpark is the very demanding tool among the data engineers, right? To work with bigger data sets. If you want to work with bigger data sets, right? So yes, if I say why PySpark and PySpark used for PySpark used for, right, just observe it is used for distributed SQL, for running distributed SQL, right? creating data pipelines, right? Yes. Ingesting data into database, for ML algorithms, for graphs and for graph or data streams, right? So it's used for distributed SQL, for creating data pipelines, ingesting data into database. Mostly, like as you see the PySpark major, you see in ML algorithms and graphs or data streams. So you are saying like, what is the need for PySpark? What is the
distributed SQL
need for PySpark? So here, if we talk about normal SQL, and here if you see Spark SQL, right? We got the concept of data frames concept available. We have got here data frames. See, huge data is there. The huge data, just you are going to process it, and you are going to make it like a structured format and create a data frame, right? Your data is distributed across multiple systems, right? Multiple systems. See, if the main advantage of Spark, see, as compared with other technologies, right? Very high speed processing, right? So your data is going to get distributed across multiple systems and are processed parallelly, right? So here your data is getting stored not within the disk level, memory level, RAM level. That's why we say in-memory computation. Spark is a in-memory computation technology, right? Because data getting stored within the memory level, data getting processed within the memory level, a bigger data sets, bigger data object divided into multiple parts, partitions we say, and stored across multiple RAMs of multiple slaves and are processed parallelly. So here we are going to create, after that we are making the data structured, creating data frames, we have got many data frame APIs. Later we can create the data frame register like temp tables and perform pure SQL kind of querying, right? So bigger data objects, if you want to query, right, which are got distributed across multiple machines, creating data frames and performing querying, right? So this kind of distributed things you can see within this, means querying, this kind of querying you can see in this PySpark. And Spark is a data flow language. It's a data flow. Spark is a data flow. Data flow means you can see pipes, means it's a collection of pipes. Means you got the output of one will be the input to the next one. The output of one will be the input to the next one. Data flow is nothing but the first, that output of one will be the input to the next one, next pipe. So creating data pipelines, ingesting data to database, ML algorithms, and for data graphs or data streams. And need for PySpark here. Need for PySpark. So if you see today, large amount of data is getting generated both in offline and online, right? You see large amount of data generating offline and through online. So these data contain hidden patterns. They contain hidden patterns, unknown corrections, market trends, customer preferences, and other useful business information. It is necessary, right, to extract valuable information from the raw data, right? So we require more efficient tools to perform different types of operations on this huge data or this big data, right? So there are various tools already. We have got various tools available. I'm not saying that we doesn't have tools, but there are various tools to perform these multiple tasks on the huge data sets. But these tools are not so appealing. So it is required that we needed some scalable and flexible tools. We need some scalable and flexible tools to crack this big data and gain benefit from it, right? So PySpark is such a kind, right? So, so for this, what we do, combination of Python and Spark will be the very efficient for the world of big data, right? So I'm combining both. We are combining Python and Spark, where Spark is the execution model, Python is the language combinedly, right? It's efficient for the world of big data. That's why Apache software community, right? Apache software foundation or community, right? Yes, it came up with Apache Spark. So it's a technology, right, for a very high speed processing. Came up with a tool called PySpark. That is Python API for using Spark. Okay. So most of them have got queries, right? Whether to go for Spark with the Scale or Spark with Python, right? So both has got the equal demand in the market, right? Depending upon the requirements, right? But if you see that Spark can be coded, Spark can be implemented by using 4 language, not only Python and Scala, right? Python, Scala, Java, and R language. Spark can be coded with Python, Scala, Java, and R language, but mostly used ones Python and Scala. By default, Spark built using Scala. Spark built by using Scala. Scala is the native language of Spark, right? Spark, but these days, if you see, even Python is mostly used or preferred, right? Where Python is used as a language, where Python has got huge libraries, many libraries for different mod. It has got different modules for different environments, right? Especially for machine learning, or if you see for graphs, not only S, for SQL kinds of queries also, right? Even we have got Python has got some modules like pandas modules, right? So just if you see the difference between Python and Scala, just observe this. See Python and Scala, right? Yes. Python, Scala. Python is dynamic typed. Dynamic typed. Scala is static typed. Dynamic typed means here in, if you say x equal to 10, based upon what value you are assigning, the variable x is going to get created dynamically. Here we don't need to say like int x or float. Okay, in this way x equal to 10 or float y equal to 4.5, right? Here no need to say like based upon the value, what value you are assigning. Based on the value assigned, the variable x is going to get created dynamically. Y equal to 4.5 means float value, right? A float value assigned to y. What value you are assigning to x? What value you are assigning to y? Based on the values assigned, the variables are created dynamically here in Python. So, but Scala is static type. Okay, but so Python is a huge community, right? Python. It has a huge community. It has smaller community, right? As compared with Python. So Python has got powerful libraries. Python contains powerful libraries. Powerful libraries for machine learning, for ML, machine learning, for graph algorithms. Etc. Right? Yes. Scala also contains, Scala also has got libraries. Scala also has got powerful libraries, but as compared to Python, like little less compared to Python. Less as compared with Python, as compared with Python. So nearly 89,300 inbuilt features, a library, inbuilt modules Python has got for different domains, right? But less as compared with Python. The mainly thing is powerful libraries for machine learning. See, if you want to go for any machine learning kinds of activities, better go for Python. That is Spark with Python, right? Yes. PySpark features. PySpark features, right? Yes. First, the main feature what we see in memory computation. In-memory computation. In-memory computation, because of which it has got a very high speed, right? So here your data object, I said your data object is going to be divided into multiple partitions. Partitions are distributed across multiple systems into multiple RAMs of multiple systems and are processed parallelly, right? Yes. In-memory computation. This even you won't see in Hadoop. Yes. Second, lazy evaluated evaluation we see, right? Lazy evaluation we say. Active evaluation or lazy evaluation, right? So which is better means lazy evaluation only, right? So on demand we can execute, right? On demand, right? Executing that, nothing but lazy evaluation means. So whenever required, you can just execute it, just like a function call, right? So whenever function, you will define function, whenever required, you will be calling it, right? At what time or how many times you want. So when required and how many times you want, you make a call. In the same way, lazy evaluated means you will define the flow, you will define the data flow. When you perform some kind of action only, your data flow executes, otherwise it won't execute. Lazy evaluation, nothing but whenever you define the data flow, whenever you make some kind of action, whenever you trigger an action, then only your data flow gets executed. Until then, it won't execute. Yes. Lazy. Active evaluation means immediately when defining execution. Whenever you define, immediately executing is nothing but active evaluation. But here, lazy evaluation means until you perform action, it's not going to get executed. Fault tolerance. Fault tolerance, it has got powerful fault tolerance model, right? You have got fault tolerant. So I was just saying that, just observe this. Your data object divided into smaller partitions. It is divided into smaller partitions and stored across multiple systems that are processed parallelly. So your data object, okay, think that here 10 lakh records, here 10 lakh records, here 10 lakh records, here 10 lakh. So they are processed parallelly. Suddenly, if any one goes down, if any system or any slave goes down, right, your data is lost. So how do this, what is that? Spark. It has got powerful fault tolerant model. It can recompute and get it right. So that fault tolerance model, separate discussion we have got, but it has got powerful fault tolerant model. And one more important feature of this PySpark, right? Persistence. No need to again and again do the same execution. No need to perform the same things, right? Operations again and again, right? No need to perform the same operations again and again. So we have got persistence means if they are persistent means available in the RAM. It will be available in the RAM, right? So it can provide its output to the next flows. Yes, it provides output to the other flows. So if I say about persistence feature, means whenever you perform any transformations, right? Transformations, a particular transformation used by multiple flows. See, this a Spark is a data flow language. It's a data flow language, right? Yes. So here data flow. But from here, the flow is going in this way. So here, if the flow is going in this way, right? So this particular transformation used by flow one, see this first flow, second, and third. So these three flows are using this particular transformation. So persist this transformation, make this particular thing available in the RAM only so that it can provide its output to the other flows, right? Yes. Persistence features, right? In-memory computations, lazy evaluated, fault tolerant, persistence, and distributed, and parallel processing, right? Yes, parallel processing. The main feature you can see is parallel processing, right? Within this. So real-time usage of PySpark. If you see coming to this, where exactly this PySpark used in the real-time scenario. Okay, yes, any query? So real-time usage of PySpark. In commercial sector, right? So if you talk about it uses Apache Spark real-time processing systems. Banks, if you talk about the bank and other financial fields, using Spark to retrieve the customer's social media profile and analyze to gain useful insights, right? Which can help them to take right decisions. Bank and other financial fields using Spark for retrieving the customer's social media profiles, right? The extracted information is used, right, to just again analyze about the credit risk assessment, targeted ads, and for customer segmentation, right? So Spark, if you talk about this PySpark, right, it plays a vital role even in fraud detections and widely used in, especially mostly used in ML tasks, machine learning tasks. In healthcare also, right, even within the healthcare. In healthcare, right, it is used to analyze the patient's records along with the previous medical reports data, right, to identify which patient is probably to face this kind of issues, right, even after being discharged from that particular clinic. So using this to analyze the patient's patterns with his history, with his health history, right, just identifying or analyzing or predicting, right? Yes. Even if you talk about, okay, in healthcare, right? One second. And today, if you see, even in the entertainment industry also, it is mostly used. In entertainment industry also, it's one of the largest sector, right? Entertainment industry also, it's one of the largest sector which is growing towards online streaming, right? Online streaming. So the popular online, if you see the OTT platform, the famous OTT platform, Netflix uses Apache Spark for real-time processing. So to personalize the online movies or web series to it. So it, if you talk about it process approximately like 450 billion events per day, right? That are streamed on server-side applications, right? Okay, even this, I mean to say that Netflix also using Apache Spark today for this. And even in the e-commerce side, right? E-commerce side, leading e-commerce websites like if you talk Flipkart, Amazon, etc. All this, they are using Spark for advertising. Even like there are some other sites like Alibaba provides enhanced customer experience and optimizes the overall performance. Apart from this, like even in the tourism industry also, right? Yes. Spark is used here to provide advice to millions of travelers by comparing hundreds of tourism websites. So these are the major things, right? Yes. So even if you talk like why we need to go for Apache Spark as come. So even we have got big data, Hadoop is available, right? Yes. If you talk, observe here, if you talk like PySpark, PySpark, right? Yes. See, observe this one. I'll come back to it. So there was a test conducted previously by Yahoo, right? Yahoo has conducted a test to check the speed of various databases. So by taking a table of 100 TB size, yes, 100 TB size consisting of 1024 columns. Yes, the test or the task is sorting based on 16 columns. And time taken for the different databases. Talk like time taken by the different databases, right? So if you talk about Oracle has taken nearly 3.5 days to process. And if you talk like MySQL has taken nearly 6 days. And we have got some specialized databases like Teradata that's just taken 4.5 hours, right? 4.5 hours. And Netija has just taken 3 hours. Okay, fine. Finally, if you see, if big data Hadoop has just taken like 3 minutes, right? 3.4 minutes, 3.4 minutes. So where is this 3 hours or 3 days or 3.5 days, right? And Hadoop has just taken 3.4 minutes. But if you talk about this PySpark, right? PySpark, right? It's 100 times faster than Hadoop. 100 times faster than Hadoop. Then you see the speed of this Spark, right? Hundred times faster means see the speed today like Spark, very high speed processing because of this in-memory computation, data storing within the memory, data getting processed within the memory, right? Because of which we see very huge. So we are going to build, it's a data flow, right? As I said. So we are going to trigger some action, then only it's going to get executed. It's going to divide into partitions, distributed across multiple machines, processed parallelly and giving the result, right? So it's 100 times faster than this. So this is what the motivation towards Spark, right? Yes. So even if you see like the PySpark job market, you can just check this PySpark jobs. You can just Google and check. Even you have got a lot of demand for it, and even see the salary packages for PySpark as compared with other technologies, right? The package will be very huge as compared to other things, right? So if you see what I am going to discuss as part of this course, right? When we have got a lot of things I'll be discussing, all each and every functionality of PySpark in brief, in depth, right? Starting with PySpark introduction, this especially for Spark with Python, especially it has got many functions it is providing, right? Especially for Spark with Python, it has got many functions where we don't need to write huge coding. The main advantage of using Python for implementing Spark, Python has got its own advantages, right? Very less code you see, simple syntaxes we see, right? For this, and many modules, wide varieties of modules you can see, right? Many modules are available for it, and we can easily go for interactive mode. And here you see why Spark need for PySpark and PySpark sessions, PySpark context, Spark context, right? And PySpark RTD, parallelizing, repartitioning, broadcast variables, accumulators, and PySpark computations, RTD computations, uh, RTD persistence features, different persist options, memory and disk options, core computations like fault tolerance model, creation of partitions, groupings and aggregations, and difference between those different types of groupings and aggregations, and various actions and transformations one by one in brief, right? Like no need to write any code, directly we can apply these things. Count by key value, sort by key, union, distinct, joins, co-group, Cartesians, other. And if you see the major advantage we see in PySpark is the data frames. PySpark SQL, most see in PySpark mostly used ones like data frames. Previously RTDs were used a lot, but now data frames are used a lot, right? And making the data structured and using map and multiple expressions. And if you see like SQL context, data frames API, various data frame APIs, and PySpark data frame creation, empty data frame, converting data frame to pandas, and show, PySpark show, row class, column class, select, collect, with column renamed, where, drop, order by, sort, group by, John, union, all right. The many UDFs available, flat map for each sample, pivot, partitioned by, yes, all this. And apart from this, if you go to the PySpark SQL functions, a lot of SQL functions like aggregate functions, window functions, data and timestamp functions, JSON functions. And if you talk PySpark built-in functions, well, so we have got a lot of functions, each and every function with some examples, right? Yes. String, translate, overlay, to date, difference, month, explode. Yes, map keys, map values, struct, row, rank, dense rank, percentage, percent rank, type from JS1 to JS1 tuple, PySpark external sources, how to create these things from external, from Hive, MySQL, narrow and wide transformation, addition of new columns, dropping columns, renaming, handling nulls, window functions, yes, yes, and deploying PySpark applications, states and tasks, drivers and executors, building Spark applications pipeline, deploying Spark applications to cluster and tuning and performance tuning, and PySpark streaming concepts, integration with Kafka, and PySpark machine learning library. Everything will be discussed, right? In brief. Okay, it's a 10 weekends. It's so everything, it's a huge syllabus we are going to discuss, right? Many functionalities of PySpark one by one in brief, right? So we don't need to write huge codings here. So it's a 10 weekend batch, like 2 to 2.5 months. We are going to complete it within 2.5 months, right? So yes, yeah, every session is video recorded. You will be getting the recorded video of it. Clear notes you will be getting session wise, topic wise, right? Yes. So even the software will be provided to you. So it will be provided to your Google Drive, yes, and notes to your mail IDs, and also videos to your Google Drive, right? Yes. Any queries from your side, anyone, right? Yes.
Daily, how many hours of session?
Yes. One second. Akshit, right? So once again I say, right? It's Spark is a execution model, and Python is a language. PySpark is not a language. Python is a language. Spark is an execution model. Both the execution model for implementing or to code, you require a language. So we use. So for example, if you talk machine learning is there. To implement machine learning, we have got many ML techniques are there. Regression techniques, classification, clustering, recommendation, pattern matching, many techniques. To implement those techniques, right, we require a language. So Python is the mostly used in implementing machine learning or data science. Even in big data, like in Spark execution model for processing, for Spark processing, right, we require a language. Coding is done in Python. Yes, real-time processing, right? Yes, Spark is meant for real-time processing, right? Yes, Gaurav. So the rate at which the events are generated at the same rate, the events need to be processed, right? So we require such a kind of technology So where you should have high speed, the rate of speed of generating of the events should match the rate of processing of the event. So Spark is such a kind of technology, right? Lightning fast technology, which at the rate, what rate the events are generated, at the same rate, the events will be processed. At one side, the events are generated. The other side, Spark will be processing the events the same speed. So it can match the speed, right? Yes. So it's for data engineering role, right? Yes, Akshit. So, but don't forget, every data scientist need to have the knowledge about this, right? Where you need to perform some kind of ETL kinds of operation. Yes. So, okay, yes, daily, see, it's not like a daily base, it's a weekend batch, right? It's a weekend batch. So it will be on Saturday and Sundays. Saturday 2 hours, Sunday 2 hours, 4 hours, but later I'll be increasing to 2.5 hours, 2.5 hours. So 5 hours will be getting per week. So if you go for regularly Monday to Friday, will be 5 hours, but you know, also Saturday 2.5 hours, Sunday also 2.5 hours, right? Yes, it is also meant for batch processing. Spark is meant for batch processing. It's not for online processing, right? It's not for a single or 2 records or 3 records. We no need to go for Spark. So for millions and trillions of records, right? For millions and trillions of records, you go for Spark. For one transactions or two transactions, no need to go for this. Millions and trillions of transactions, we go for this, right? Yes, it's for batch processing, right? So here one thing, yes, if you bigger data sets will be taken, right? But not based on the data sets that you are going to process. You are just based on the schema and how we can process it, right? So if you got whatever it is, 5 records or 5 lakh records, the coding is not going to change. If you got 5 records or 5 million records, your coding remains the same, right? Yes, most of the things, mostly we go for, mostly in Spark, right? Data frames mostly used. Data frames are mostly used, right? Making the data structure, right? Okay, Python is mandated to know for this course, right? Okay, so even if it doesn't have knowledge on Python, right? Yes, just I'll be briefing you about, right? For some one session or two sessions, I'll be spending on this Python before I'll just give a brush up on all this Python. Python is not a kind of technology where you can learn, you can just update by yourself also. Simple syntaxes, very easy to learn, right? Yes, I'll just, before I go with the practical part, I'll just brief you about those things, right? Yes, yes, structured, unstructured, right? So semi-structured, so taking some kind of other data, right? Data, some weblog data, URL data, JSON data, XML data, right? This kind of data also I'll be working with. Yes. Yes, roles and responsibilities, other things, right? And resume building, other things, everything. At the end of this course, right, I'll clearly provide all those things, right? Roles, responsibilities, and resume building, other things, right? Yes, how you can apply, and some sample resumes I'll be forwarding you. Yes.
Maybe do we need to complete Hadoop and Spark and Scala course before starting this? Not required.
So here, okay, just basics of HDFS required, basics of HDFS. HDFS commands knowledge is required. No, if other things even are not that much, but even the things, the basics, whatever required for this PySpark related to Hadoop, right? If not possible, I'll just provide you that basic videos of this. You can just go through of those things. If anyone doesn't have knowledge of the basics, right? So not a problem. Only HDFS knowledge, some is required, and some scoop knowledge is required. Means how to pull the data, from databases to HDFS, right? That knowledge is required. So if it doesn't have knowledge, I'll just provide that basic videos of this Hadoop, right? HDFS. Not all the videos, like HDFS and scoop, basic videos of it.
Because currently we are in evening batch, Hadoop. Currently we are having Hive.
Yes, I can. The basics of HDFS required. So not it's not 1 day or 2 days. Yes.
Okay. Yeah.
So yes, Manjunath, right? Yes. At the last, I'll be discussing those kind, right? At the end of this course, I'll also give you the knowledge on those things. So in here, mostly we work with, yes, lambda expressions, lambda things, right? Triggering this lambdas, right? Yes. Yes, Kiran, mine. Yeah, even about in this cloud side also, how it is used and how we are going to use it also. I'll be providing you that knowledge on those things, right? And even you can see PySpark total functionalities, the various APIs of this, right? PySpark, everything in brief, one by one, we'll be discussing with multiple examples, right? So that's the way I'm saying it's 10 weekends. It's not like 6 or 8 weekends, right? It's 10 weekends. We'll be spending more time on this in brief knowledge. You'll be getting the command on this. Even for streaming, even sometimes I'll be at the end, I will be also showing some kind of streaming data. How to work with streaming data means data which keeps on incrementing, the data which keeps on generating such kind of data using this Flume and Kafka, right? Like how we can integrate like Spark and Kafka integrate. Some integrations like Spark Kafka integrations, Spark Hive integrations, Spark database integrations, like Spark NoSQL, like NoSQL database integrations also I'll be showing during this course. Yes, Panindra, yes. So yes, I'll be showing you how to run this, right? Even on this each weekend how many hours, right? So Saturday 2.5 hours, Sunday also like 2.5 hours, right? So like you'll be getting 2 hours on Saturday, 2 hours on Sunday, 4 hours. Later I'll be, when I'll go with the practical part, or later in working with Spark SQL. If not required, I'll be increasing to 2.5 hours, right? Yes. Yes. So the timing of this will be like 4:30 to 6:30, right? Yes, 4:30 to 6:30. Saturday 4:30 to 6:30, Sunday 4:30 to 6:30 is this batch timing. So tomorrow also you can attend the session, right? Everyone, you can attend the session to see more on this, right? So just today was introductory session, what we are going to discuss and what is tomorrow we'll be discussing in brief more on this. Tomorrow it's not like any duplication of today's, but we'll be continuing from here on to see more on this, right? Yeah. Any more queries, right? Any more queries from your side, anyone? So basic knowledge of Python required, but still I'll be providing that for 2 sessions. Just I'll be briefing you about all this Python functionalities, right? Yes. Yes. At the end, I'll also just show you like how to see this Spark and Kafka integrations, right? Yes. Okay.
Sir, good evening, sir. Hive and Spark with Scala, these are all knowledge mandatory, sir.
So the Hive is okay. So Hive HQL is similar to SQL only, right? Even that some basic means how to create it, how to that knowledge. If you're not aware, right? So like basics of from Hadoop, what you can take is basic HDFS, basic scoop, and basic Hive knowledge required, right?
But we don't know that when we are providing any classes.
Yes, I'll provide some videos. It's not a, it looks like normal SQL only, right? HQL also similar to, HQL is similar to SQL only, right?
Yes, sir.
So how to work with those things before I go with the integration part, either I'll ask you to go to the video and come. If you have got any queries, you can ask me up there. Before I start with those kind of topics, that I'll just, if any prerequisites are there, I'll just provide that step-by-step explanation is provided in that videos, right? So just not all those, some videos, right? Basic videos. Yes, definitely. I was saying, right? You'll be getting great command after this course, right? With all these functionalities, right? RTDs concept, data frame concept, DS streams concept. Right, yes.
Any cloud knowledge mandatory, no, sir?
Yes. So I'll said I'll also provide you those things right at the end.
Okay.
Yes, yes. Even for this, yes, it is helpful for designing Azure Databricks also, right, for notebooks. So here I'll be showing you in this Jupyter. I'll be different environments. I'm going to show you, right, in this Jupyter notebook and Spider ID. There's some IDs I'll be using like Spider ID, PyCharm ID, Jupyter notebook. Yes, and Google Colab, right? And within this VMware also, I'm going to provide these things, the PySpark running on this, where I'll be giving you that VMware where you can see all these components, Spark, PySpark, Spark with Scala, and other all the Hadoop components you can see, right? You can work with it. And okay. So fine. So if I'm done with the queries, then I will sign off for now. Meet you tomorrow, right? Same time at 4:30. To see more discussion on this, right? Yes.
Once you show me that notepad, sir.
Which one?
Notepad, sir. What
Yes, yes. 1 second. 1 second. These things I'll be forwarding you, right? No, notes, whatever it's. Okay.
Sir, basic Python is enough, no, sir. Actually, I'm your batch 9 o'clock student, sir, actually.
Yes, yes. Basic Python is enough. No, okay. No need of total advanced Python, all those concepts not required. Basic Python knowledge. And mostly like you need to have the knowledge of functions, right? So by the time we go deep into this PySpark, okay, you will be completing those things, right? So basic Python is enough. That's enough, right? So for the first 2 weeks, right, we'll be discussing more on these environments, installations, modes, and RTDs, those things, right? How they are computed, how they are created, those things, right? Yes. Fine.
Sir, one question. What if I miss 1 or 2 classes in between? Because it may happen.
So yeah, not a problem, right? Yes. So it's a weekend batch. We might be having multiple. So you'll be getting time only on the weekend. So many people can miss the session. In such case, you'll be getting the recorded video that day itself, right? At 6:30, for example, 6:30, the class gets completed. By evening 8:30 or 9 o'clock, you'll be getting the recorded video session, right? It's only,
Okay.
it's only viewable. It's not downloadable. You can just view it. So if anybody on Saturday, if they're absent for Sunday session, you can be ready with going through the video, right? So every day, means every session is recorded. Every session will be recorded. You'll be getting the recorded videos of it. Even if you're absent because of some job timings, if you're unable to attend, or because of some ill health, or because of anything, you can just go to the video. Still, if you got any queries at the next session, at the end of the session, you can spend time for your queries. Yes.
Signing, and you will use Azure platform or AWS or Google?
Pardon? So just I am going to show you this cluster on this cluster, right? How we are going to execute these things.
Are you providing interview questions?
Yes, 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 yes. Many interview questions at the end. Some sample resumes, interview questions I'll be providing at the end, right? Yes.
Sample resumes in the sense you are providing as per big data
Yes.
resume, right?
Yes, yes, big data environment.
Okay. Actually, I'm looking for Azure environment. I mean, Azure data environment.
Yeah, big data environment only. Just the resumes will be from big data environments, right? Yes. Fine, right? Okay. So I'm stopping here. We'll continue tomorrow. Same timing at 4:30. You can follow the same link to see more on this, right? Yes. Thank you all for your time. Thank you. Yes.
So tomorrow also same time?
Yeah, same time you can follow, same time. Same link, right?
Okay, sir. Thank you, sir.
Yeah. Yeah, good evening all. So before I start, can anyone please confirm whether my voice is clear, whether the screen is visible or not, right?
Yes, sir.
Fine, thank you. So in the last yesterday session, right, just I was briefing you about what is PYSPARK, why PYSPARK, right? So yes. So what is Apache Spark for big data analysis for processing and computation, right? If you see more on this, Spark was developed, the personality who developed, right? Spark was developed by Matei Zaharia, right? In AMP lab. It was open sourced. Spark was open sourced, right? In the year 2010, Spark was open sourced. In the year 2010. It was donated to Apache Software Foundation, right? It was donated to, yes. It was donated to Apache Software Foundation. In the year 2013, right? In the year 2013. So it was developed, it was open sourced in the year 2010, and it was donated to Apache Software Foundation in the year 2010, used for big data analysis and processing and computation, right? Used for big data analysis, processing and computation. Why PySpark? As I was discussing, like why PySpark. So before that, why PySpark, right? Why PySpark? Yes. Yes. I defining Spark, right? If I want to define Spark, defining Spark. Yes, I define Spark in 4 lines, right? So 4 to 5 lines. Yes. Spark is a open sourced. Yes. Sorry, there was a connection problem, right? Fine. Now is my voice clear and audible to all, right? Yeah, can everyone please confirm once again? Is my voice clear? Fine. So
Thanks, sorry.
Spark, I defined Spark in 4. Yeah, it's an open source distributed execution framework, right? Distributed execution framework. Cluster computed in-memory computation with parallel process style. With parallel process style. For large scale data processing. For large scale data processing, right? Yes. So here Spark is an open source distributed execution framework, cluster computed with in-memory computation feature, and with process style, parallel process style for large scale data processing. Large scale data processing, right? Yes. Okay. So Spark can be coded with different languages. Spark can be coded with Scala by default. Actually, Scala by default. But as compared to Scala, right, today like Python has got many libraries, many built-in libraries, right? Even for, especially for graph algorithms, machine learning, these techniques, right? And for recursive algorithms. So that's why Python also mostly used, both the Python and Scala are mostly used, right? Right, and Java also can be used. So multi-language support. Spark is a multi-language support. It can be coded with Scala, Python, Java, and R language. Like R language also, right? Yes. Spark can be coded with Scala, Python, Java, and R language. And if you say why PySpark, right? Yes. It is the Python API, right? It's a Python API to use Spark. So why PySpark means PySpark is the Python API to use Spark. Sorry. So what is PySpark? Is a lightning fast technology. Lightning fast technology. It's a lightning fast technology. Yeah, that is designed right for fast computing. Designed for fast computing, right? Yes. Is the lightning fast technology that is designed for fast computations, right? I can say like PySpark is a demanding tool. It is a demanding tool among the data engineers, right? Among the data engineers to work with bigger data sets. Okay.
Sir, will you share this notepad with us?
Yes. That's why I'm preparing notes parallelly, right? So no, okay. This everything I'll be forwarding. PySpark is the Python API to use Spark. It's a lightning fast technology that is designed for fast computing. It's a demanding tool among the data engineers to work with bigger data sets. So next, okay. PySpark used for what? So PySpark used for, yes, distributed SQL, creating data pipelines, ingesting data into database, running ML algorithms, graph data streams, right? Yes. So yes. So using we can also write a data into data. I can create a database table. So from a data frame. So Spark data frame is there. The Spark data frame I can write into a database. So a table gets created. I can read the data from database directly. Spark can read data from database directly without the use of any scoop and directly Spark can write into the database. And Spark can integrate with any databases like Spark can integrate with Hive, Spark can integrate with database like MySQL or any other, and Spark can integrate with Hive and NoSQL databases. Creating data, I said Spark is a data flow language, right? So collection of sequence, collection of pipes. At each pipe, either transformation, filterings, groupings, aggregations, or sorting, you are going to see that. Yes. So if you see the various, we have got some PySpark mini packages available, right? Yes, as compared with the Scala, right? PySpark packages. Just PySpark itself is a package. And within that, we see like sub package PySpark.sql for SQL operations, for data frame creations, many SQL functions it supports, right? And even PySpark is supporting many modules, right? Many modules and functionalities, even for streaming, right? Even for streaming, if you see like a Spark streaming, micro batching, right? Quick results. I want quick results, right? For every 2 seconds, I want some updates. For every 5 seconds, I want updates, right? Yes. And also not only for that, even like Python is mostly chosen, right? Where Python itself has got many modules. Right? For machine learning, like if you see like Pandas, Matplotlib, NumPy, CP, Scikit-learn. But still PySpark has got, right? PySpark.ml has got many modules and functionalities, right? And even PySpark.mllib, right? Yes. Okay. So if you say like Spark plus Python, so Spark is once again I'm saying Spark is an execution model plus implemented by using a language called Python. Spark and Python combined is like PySpark. Execution model implemented by using a language called Python. Not only multi-language support. So generally, yes, we have got HDFS. So generally, okay, just I'll show you this, right? So this is your HDFS, we say. Hadoop distributed file system. We say like big data Hadoop, right? Hadoop has got HDFS. So Hadoop is meant for two things: storage and processing. Storage and processing, right? Yes. For storage, it doesn't use any database, right? Because databases has got some drawbacks. Means limited storage databases. Most of the databases, no parallel processing. If volume keeps on increasing, right? Means if you see, if you want the total amount to be calculated for 10 records or 1,000 records or 10 lakh or 1 crore, if data volume increasing, speed decreases, right? And mostly like we talk about the databases can handle only structured data. So despite of all this, it's not going with the databases for storing its data. It's going with a file system called Hadoop distributed file system. Hadoop is meant for two things: storage and processing. For storage, we go for HDFS. not any database, because I was just saying like you have got some drawbacks with it. So despite of this drawback, still Hadoop doesn't goes with database. It's going with a file system called Hadoop distributed file system. And also for processing, Hadoop used to use MapReduce. MapReduce was widely used. If you go back like in the year 2012, 13, 14, 15, 16, right? MapReduce was widely used, but now MapReduce is got outdated because of this huge codings and many lot of programming required for this. So we are using Spark. So for storage and processing, and for storage HDFS, and for processing, now we are going with Spark execution model, right? We are going with Spark execution model. Spark has got very high speed, right? Spark has got very high speed processing. So computation, right? Storage happening within the memory and processing also within the memory, because of which we are going to get huge, very high speed. So Spark, again, implementation. Spark has got implementation using coded with multiple languages. I was saying like Python, Scala, Java, and OR language. So, but Java is never preferred. Only some less companies like only some companies, only like couple of 1 or 2 companies, right? They'll be preferring for Java, but OR language is never used. Okay. Python and Scala is mostly used. By default, Spark built by using Scala, right? So Java means, I was saying some companies like Value Labs, or a couple of companies, 1 or 2 companies only are using Java, Spark with Java implementation. We see like huge codings here, but Scala mostly preferred, Python mostly preferred. But nowadays Python is mostly used, right? That's got for especially for ML techniques, ML algorithms for implementations, right? Where PySpark providing many built-in functionalities. Even Python itself has got many modules, right? So total, if you talk about ML, machine learning or data science, total implementation goes in Python, right? Yes. So from different databases, OLTP, online transactional processing, think database 1, database 2, database 3, think branch 1, branch 2, branch 3 databases. From this, you are going to pull the data. You are going to pull the data from these different data sources, different OLTPs, online transactional processing. Generally, how to pull the data? You use a component called scoop import. Scoop import, right? Scoop import. Scoop is nothing but SQL plus Hadoop. Scoop import. Into HDFS, you are going to bring the data. You are going to bring the data from different sources to Hadoop. From Hadoop, from HDFS, right? You have many processing components. Previously, MapReduce, Pig, Hive, or they used to take. Now, from this HDFS, your Spark is going to read the data. Spark is going to read the data from this, read the file, and it is going to process it. Process. And again, after processing, again, it can store the data into HDFS. After the result again can be stored in HDFS. Again, from HDFS, you can move that result back to the databases, to the websites. So again, okay, your data is moved to the databases. Otherwise, even I was saying, right? Spark can directly, no need of, okay, Spark can directly read data from this database and write data to database. It can read, it can write directly without the use of scoop also. Without scoop also, directly Spark can read that entire table, and it reads the table. This is your database table. This is your database table, right? Table. This table, Spark reads and creates a data frame. It creates a data frame. Data frame is also a structured one, right? With rows and columns. Yes. Again, this data frame, if you want, it reads, Spark reads. And again, this data frame, if you want to write into database, you can write this data frame, you can write and save into the database. So this both, you can perform all this, right, using Spark. So Spark plus Python, Spark and Python combined, we say like PySpark. And I was just saying like Python and Scala, which are mostly preferred. What is the differences we see means? So Python is dynamic typed in the sense, variables that what we are creating, variables x equal to 10, y equal to 4.5. Like C language, like Java, we no need to say int x, float y. What value you are assigning? Integer. So integer variable creates. What value you are assigning to it? Float variable getting created. Z equal to a list 10, 20, 30, a list of values. What type of variable Z is? List type. How it is list? Because you are assigning a list to it. So based on that, what value you are assigning to this, based on that, the variables created dynamically. It's dynamic typed. Scala is static typed. And we talk like Python has a huge community, right? It has got huge community. It is small community, is smaller. So we say like Python software foundation, right? And Python contains powerful libraries, right? For machine learning, graph and iterative algorithms, less as compared with Python. And if we talk about the PySpark features, main PySpark features, right? In-memory computation, PySpark features in-memory computation. So within the memory level, we can just load and we can just process within the memory, right? That's why we call it as in-memory computation. And lazy evaluation, right? I was saying lazy evaluated is best suited for Spark, which is lazy evolution or active evolution, which is good. Lazy evolution means on required, you are going to execute. When required only, you will execute. Means on demand. By performing an action, we execute the entire flow. Spark is a data flow language. So the entire data flow gets executed only when you trigger an action. Until then, it won't execute. Just like a normal function. When you call the function only, it executes. If you're not making a call, when you make a call, at that point only it executes. Any number of times it can execute. Here also, we need to compulsory trigger an action to execute a Spark data flow. Fault tolerant. I said like Spark data objects are divided into multiple partitions stored across multiple RAMs of multiple slaves. If you talk about the Hadoop, it's stored within the disk level, right? But in Spark, what the data is storing means disk processing compared with memory, right? RAM processing has got very high speed, right? Fine. So already Hadoop has got very high speed as compared with the other technologies, right? Still, but Spark has got because of in-memory computation. But during the processing, as Spark processing happening on within the cluster level with multiple machines, right? The data is distributed across multiple machines and is processed parallelly. During this process, as they are machines, if any one slave goes down, right, then Spark has got powerful fault tolerant mechanism, right? It can rebuild. There won't be any data loss. And there won't be any failure, job failure, right? So that I'll be discussing in brief about the fault tolerance, how Spark is able to rebuild the data and how it is recomputing, right? Yes. And persisting.
Sir, HDFS means storing the data at disk level.
HDFS, yes, HDFS, right? Hadoop distributed file system. See, every node in your cluster, okay, one second. So one more thing, Hadoop or Spark, what we discussed, right? So it is not for client server architecture. I'm coming to your query only. It is not a client server. It's not for clients. It is not for request response. It is not for request response. It's not for online applications. It is not for online processing. So first thing what you need to understand, Hadoop or Spark is not for online processing or online applications. See, there are two types of applications, online and batch applications. Online applications or batch applications. Online applications means user interactive applications. User interactive applications means user gives the input here. Until the here batch applications means user non-interactive. User non-interactive applications. User doesn't give any input here. These are the applications which runs in the background. So here where you see millions and trillions of data, where records, for example, right, millions and trillions of records. For example, generating credit card statements for millions of customers. Here user doesn't give any input. If you're making a single online transaction, right, you are going to give the input from source account to destination account compulsory. Without that, the online transaction, booking a movie ticket also, right, user interaction required. But here for batch applications, yes, user non-interactive, right? So if mobile bill statement generation, credit card statements generation, for example, allocating a railway ticket means your waiting state is 200 or 150 or 100, right? Here user is not performing anything. It's happening in an automated fashion. So batch applications where we see millions and trillions of records. Online for a single transaction, two transactions, we won't go for this Spark or Hadoop, where we involve a lot of records. And that too, whenever a user gives a request, immediately it's not for request response. It is for master slave. It is what? Master slave. So where we see a master and multiple slaves. Slave 1, system 2, system 3, or slave 1, slave 2, slave 3. Means your data object, Spark data object, your data is going to be divided into multiple partitions. You think it's a bigger data object. This data object, assume your system 1 TB, 1 TB, 1 TB is your capacity. So this, if you think you have got a data object of 2 TB, which cannot be accommodated in it to any of this. So data will be divided into partitions. Data divided into partitions. Data divided into partitions, and these partitions are going to be stored across multiple systems. They're going to be stored across multiple systems. Okay. Okay, so here data is divided into partitions. Partitions are stored across, not in the disk level, in the RAM level, memory level, right? Data is stored within the memory, within the RAM, and are processed parallelly. So the difference in Hadoop, you see like disk processing stored within the disk. That is, so every node, every system, this is master node and this is slave node. Yes, I'm coming to this. You are asked to your query. So every node will have local file system, Linux, and Hadoop distributed file system. Local file system, Hadoop distributed file system. Local file system and Hadoop distributed file system. Hadoop distributed file system, right? Where you won't see any data, you cannot create a file in HDFS. Hadoop distributed file system where you cannot create a file, there is no file editors. You are going to bring the data or pull the data from different data sources into HDFS. You are bringing the data from different, okay. And the data splitted into multiple partitions and distributed and processed parallelly, because of which very high speed memory level processing, right? Yes. Distributed, I said. Persistence means there's one more feature. Persistence feature means transformation. Again and again, you cannot re-execute the same transformation again and again. The same executed transformation itself, no need to re-execute. We can persist it. Okay, about this persistence, I'll provide you multiple examples to make you understand. One thing you can remember is transformations cannot be reused in the case of Hadoop or other things, but here in Spark, you can reuse the transformations. No need to write again and again. No need to write again and again. Distributed, Spark is distributed, right? Distributed RAM you are going to see. See, for example, there are 10 RAMs are there. Each RAM capacity 8 GB. Total RAM capacity how much? There are 10 systems. Each system has got RAM of 8 GB. Total RAM capacity, distributed RAM.
80 GB.
Means it can accommodate 80 GB file, right? We can accommodate 80 GB file into the RAM. Okay. So I'll just say, and one more thing you need to understand, you may get multiple queries when I say, right, data is stored within the RAMs and processed within the RAMs. How can, okay, I'll just come back to this Spark data storage and processing, right? Yes, and parallel processing.
Sir, if you don't mind, in future are providing any definition about these features, sir? In memory, lazy, fault, this, sir?
Yeah, multiple examples.
Not examples, sir. Definition of these features.
In memory computation means what? In memory computation means data storage and data processing happening within the memory level. Observe here. Okay. In memory computation is nothing but storage and processing happening. Okay.
That's why I'm asking, sir.
Storage and processing happening within the memory level, So these things just we'll be discussing in these features in brief again. Yes.
Yeah, that one, okay, sir. Single definition is important for
storage and processing happening within the memory level.
Yeah, thank you, sir. What about lazy, sir?
Within the memory level. Within the memory level is nothing but RAM level, right?
Yeah.
Lazy evolution. Lazy evolution means the data flow won't execute. The data flow, Spark is a data flow. Data flow means, see, observe this. For example, this is your data object. D1 is your data object. This has got some 1 lakh records. Assume. From this D1, I'll apply some transformation. Filtering operations I'll apply. I'll apply some filter operation. The result what you get is D2. D2 has got how many records? Some 50,000, 50K records only, because some records got filtered. On this D2, again, I'll perform some transformation where modifying or some transformation you will apply. You will get some D3. From D3, again D4, some filtering, mapping, grouping, aggregating, sorting. Some operation you perform on each one, right? This is your entire data flow, we say. In the data flow, first your data object, if some filtering, next some mapping, some grouping, some sorting, some aggregations you will apply. This data flow, finally the default result, the final result D4 should be collected, right? So to collect it, the data flow won't execute immediately. Whenever you define this, they are not going to get executed until you trigger some action, D4 dot action. Whenever you apply D4 dot action means from the root onwards up to this D4, it executes and gives the result which can be collected, right? Means whenever you perform action only, the flow is executing. Okay, fine. That we call it as lazy. The data flow gets executed. The data flow gets executed only. So the data flow gets executed only when we perform an action. So we have got different types of actions. Wait, later I'll brief you. Means lazy evaluation. Means, for example, lazy evaluation, active evaluation means, for example, if you are writing notes, daily you are attending sessions, you are writing notes. Immediately you won't read, right? For example, if you are reading, it's active evaluated. Means only when exam is kept, then you are reading, means it is lazy evaluated. Only when exam kept only you read. If no exam, you won't read, for example. Means it is lazy evaluated. Here also, Spark data flow, you are defining the data flow, entire data flow. But when you perform an action only, it executes. Otherwise, it won't. That is what lazy evaluated. Just like one more example, like I was talking about the function. If you talk about a function, right? If you define a function, it won't execute until you make a function call. If you make a function call, then it executes. That is what lazy evaluation. Fault tolerant. Multiple tasks executed by multiple slaves. Slaves means systems. If anyone slave fails, if anyone slave goes down, fails, then that task will be allocated to other slave. If I give a labor example to make you understand, right? So for example, if you take any education, for example, a college, so daily you will be having some periods, right? Some 5, 6 or 7. Daily you can see like 5 to 6 lectures happening. So 6 faculties taking the sessions. If any faculty is absent, right? During the absence, some other faculty will replace that session, right? Means in the same way here, if during the processing, if any one slave goes down, means if any system fails, right, immediately that task should be allocated to other slave, or even there should not be any data loss where Spark is going to recompute. So we have got a lot of discussion on this fault tolerant. Means the task gets, if any system fails, then immediately the task need to be assigned to other slave. Persistence means any transformation that can be in Spark. We have got a feature, right? Spark any transformation can be reused. Transformation can be reused, right? So to make you understand this persistence and lazy evolution, right? Yes. So I'll just lazy evolution and persistence to make you understand, right? Just I'll give an example, right? So later I need to discuss these things later, but so Spark objects, Spark data objects, we call them as RTD. We call it an RTD, resilient distributed data set. Resilient distributed data set. So Spark data objects, we call it as resilient distributed data set. Okay.
Sir, we can use Spark for interactive queries also, right?
Yeah, interactive queries also, SQL queries. Spark SQL, so separately we got a component Spark SQL, right? Spark SQL component.
Sir, but you mentioned that we cannot use Spark for interactive
Where?
in the previous paint pick.
For interactive, yes, Spark can be used for all purpose. Previous one.
Yeah. Not here.
Online versus batch. You are saying online transactions versus batch in that example.
Yes, sir. I think that meant.
Okay.
No, it mentioned it's not a client-based interaction, right? So that's what he's asking the question, I think.
So yes,
Yeah.
yes.
That's the
Yeah,
same thing.
yeah. Hadoop is not for online processing, right? Online processing. Yes.
Right.
Hadoop is not for, yes, Hadoop is not for online processing. So so if you want to Hadoop are, see what is it, big data, Spark and Hadoop is not for online. See for one record or two records, for one record or two records we cannot go. But if you want, see for example, if you got some bigger data object, whether it is structured or unstructured, first you will bring it, you will process it, and finally you can create some tabular structured format. Unstructured to structure, I'll make it, and I'll make a table structure. The table structure, I can perform some kind of querying also can be done. SQL querying, structured query language, right? SQL querying also I can perform on this. So interactive queries, you can interact with this, right? With any queries, right? You can make the data. So if you have got Spark has got a component of Spark SQL, so where we see data frames. Data frames are widely used, mostly used, right? We create a data frames. Many data frame APIs available. Otherwise, data frame you can register as a temporary table, and you can perform many querying, interactive queries, right? Spark is designed for interactive queries. Interactive queries is different, and this online processing is different. So on whenever, okay, a single transaction, right, or two transactions, three transactions, right? So it's not, see this Hadoop or Spark is bad for small data, good for huge data. These are for huge data, right? Huge data objects, good for huge data. Means simple example I say, means here your data is going to be divided into multiple partitions. The partitions stored across multiple systems and are processed parallelly. For a small data object, for a very small data object, splitting, storing, again retrieving is a time-taking process, right? So for that, you can just go with this databases itself, right? So here we are meant for batch processing. One thing is batch processing. Okay, so millions and trillions of records processing, right? By dividing and partitioning into multiple parts, storing across multiple systems and processing it. So it doesn't, once again, online processing means client server architecture, client giving the request, server giving the response, right, for this. But if you want to perform this kind of processing also possible, I'm not saying directly not possible, indirect. So if you want integration with NoSQL databases, either Spark integration or Hadoop integration with NoSQL database, where this Spark can perform batch processing and this NoSQL can perform online processing. Both combinedly can perform both batch and online processing. See, one thing in real time, we will see a lot of integrations, right? Yes. So here, Spark. So if you want the online processing, NoSQL databases are available. Cassandra, MongoDB, HBase, right? So this can perform batch processing. Batch processing means where user non-interactive applications, where huge NoSQL databases means you can perform only on a single record updation. Here you can update only single record, but for massive updations, you go for Spark or Hive, massive updations, lakhs of records updating. NoSQL is for online processing. Online processing. Combinedly, both can perform batch and online processing. And if you want live streaming data also, live streaming the data. If you want to work with live streaming or capturing live streaming data, and processing it, right? So Spark can process. So you need to integrate with Kafka. Kafka is for live streaming and even for live streaming and messaging also. Okay. So these things, if you want to be used for different, right, batch and online processing, and for streaming processing, for streaming also, right? Yes. And Spark, real-time processing, we say. Spark is real-time processing. We can perform real-time processing. See, for example, today some 1,000 transactions happened. At the end of the day, you have detected some 20 fraud transactions happened. 20 fraud transactions happened, right? But what is that? Immediately whenever fraud happened, what do you mean by real-time processing? Means immediately whenever fraud happens, then saying that the fraud has happened, right? So not after 1,000 transactions happen at the end of the day saying that some, but real-time processing means then and they're saying that a fraud has happened. So today fraud happened, after 2 days detecting that fraud has happened. That is not, but real-time Spark can go for real-time processing. Means, see, for example, if you take Spark and this live streaming. So if I talk about live streaming data, I was saying like yesterday, I was saying like Spark used to, even for Netflix is using Spark today. Events are generating. Live streaming means events are keeps on generating means at the same rate of speed, the data need to be processed at the same rate of speed. The data need to be processed. Means we need to have a very high speed processing technology like Spark, right? For that. So at the rate of speed of the event generation should match the rate of the processing it. So Spark can do it. At one side events generating, at the other side Spark will be processing the events at a high speed. So yes, Ramu ji, and how to work with this, see what is the Databricks and how to work on it, right? Everything I'll be discussing as part of this. Not only that, different environments I'll be discussing like Databricks and how to work with Anaconda distributions like Jupyter, even on IDs like PyCharm and IDs like even IntelliJ also I'll be showing you, right? And also like in the cluster level on VM, how to do that, everything, multiple ways I'll show you, right? Even on Google Colab also how you can work, right? Yes. Okay.
Hello. Yeah, actually, yesterday I did not attend the class. I'm not sure whether you covered this point in the yesterday session. This is the question I have is, so what is the prerequisite? Do I need to have the understanding of the Spark system and how it will work to attend this session? Just I want to know the prerequisite of this one.
No.
To attend this.
Everything Spark execution model, everything I'll be discussing in brief. Not required.
So
Spark execution model in brief I'll be discussing. Spark features, computation, persistence, fault tolerance, lazy evolutions, in-memory computations, how processing happening, and where are the different persistence levels, fault tolerant.
Spark ecosystem, all about Spark
Yes,
ecosystem.
yeah, Spark ecosystems. Everything we'll be discussing as part of. No need, right? Yes.
So what is the duration of this session? I mean, this.
So it's a weekend batch. It goes for 10 weekends.
So per weekend, how many hours?
So 1 second. So every week it goes for 4:30 to 6:30 or 7 it goes. 4:30 to every day. It means every Saturday and Sunday. 2.5 hours on Saturday and Sunday. It means 4 to 5 hours per week you'll be getting. So it goes for nearly, if you go for 10 weeks, 45 to 50 hours we'll be spending on this, right?
Okay.
So I'll just once again I'll show you what I'm going to cover as part of this, right?
Yeah, that would be very helpful. Thank you.
Okay, and one thing, just observe how the Spark. Just I'll give overview as of now to just understand how the Spark data objects we call it as RTD. Spark data objects. If you are loading any file, if you load the file path you provide, file path, some f1.txt file. So from that, using Spark context, if we load that file path, then RTD getting created. RTD has got, think that you got some lakhs of records. From RTD1, if you perform any transformations from R1, R2 getting created. From R1, R2 getting created. How R2 getting created? R1 has got 10 lakh records. If you filter, you got some 6 lakh records. 6 lakh records means R1 has got 10 lakh, R2 has got 6 lakh. Okay. From R1, R2 getting generated. From R2 again, for example, all the employee names, 6 lakh employee names, starting with lowercase. I want to just to transform all the employee names to uppercase. Map operation, map functionality. Again, you get R3. In R3, you see all the employee names in uppercase. Otherwise, some IP address I'm generating from the whatever the location. From their locations, I want to know their IP addresses. Or from the IP addresses, I want their city names to be generated. Or from R3, R4 gets generated. Some transformation, grouping operation or sorting operations. Means here, okay, R4 to R5. Observe carefully. This entire flow we call it as a data flow. Data flow, right? Data of 10 lakh records, 6 lakh. Again, here I want only particular Hyderabad city records only I want. Again, filtering happened, only 3 lakh records you got. Means data flow, right? So this data flow executes only if you perform some kind of action. Action means you got some, for example, R5 dot collect or dot action. Later I discuss what are that. Whenever you perform this action, right, then only from the root to this, first R1 gets loaded into the RAM. First R1 gets loaded into the RAM. R1 divided into multiple partitions and gets loaded into the RAM and processed. Next, once the processing finished, once that execution is finished, right? So the result R2. Now when R2 is ready, see one thing, the RTD size is very large. Think it is some 10 TB or some 5 TB, or at least you say 2 TB it is. To accommodate 2 TB, how much RAM capacity? 2 TB RAM need to be maintained. 2 TB RAM need to be maintained because all the data to be stored within the RAM level, right? But 1 RTD, 2 TB means 5 RTDs, how much TB required? 1 RTD, 2 TB means 5 RTDs. Data of 10 TB, right? To provide 10 TB RAM means it is a huge task, right? So here RTD is resilient distributed data set, RDD. Means all these RTDs at a time, they won't be loaded into RAM. If at a time they are loaded into RAM, they cannot be accommodated into RAM. They cannot be accommodated into RAM, right? You cannot provide that much of space, right, to accommodate all this RTD. When R2 from R1, R2 got created, R2 got computed, R2 computation finished, then R1 will be removed from the RAM. Observe here, R1 gets removed, R1 and its partition gets removed. Now what is present within the RAM? R2 is present within the RAM, and R2 partitions are present within the RAM, right? Yes. Okay.
Sir,
Yes.
how it will remove the R1 automatically, or like we will need to
No, automatically. So
automatic?
that is the feature, right? So when R2 is ready and computed, all the R1 partition gets removed.
So
Now
it's removed from the memory or SDFS, like hard disk?
from the
Right.
memory,
Okay, backup
So-
will be available in the hard disk.
So whatever we are talking is in-memory computation, memory level, right? So once from R2 to R2 partitions load across the RAMs of multiple systems. Now R3, the result, whatever we get R3. Now when R3 is computed and processed, when R3 is ready, R2 gets removed from the RAM. Only the current RTD will be present within the RAM. When now R3 output is there within the RAM, R3 output is taken as input by, see here, once R1 output is taken as input by R2, R2 output is taken as input by R3, R3 output is taken as input by R4, right? Once R3 is ready, R2 got removed. Now R4 computation finished, loaded and computed into the RAM. Processing finished. Now R3 gets removed. Now R4 loaded, computed. Now when R5 is ready and R4 gets removed. Once the total execution finished, once the R5 output is collected, final output is collected, R5 also gets removed from the RAM. Now what is present within the RAM? Now what is present within the RAM? Which RTD present in the RAM?
Right.
R5 also removed from the RAM when output is closed.
Output, R5 output.
Now what is present within the RAM means nothing. No RTD present within the RAM. All got removed. One by one RTD gets loaded, they gets removed. And finally, if you come to that, right, all the once the output is collected, that R5 also removed. Now no RTD in the RAM. Now next you can trigger the next flow. If you trigger the next flow, once next data flow, again the next data flow also one by one RTD. Triggering means once you perform the action only, the data flow gets executed, right? Next flow also one by one RTD, they get loaded and they will be processed.
Sir, then where the output will be stored, the final output?
Final output will be stored at the client side. The system from where you are triggering, right? From where you are performing that, from where you are submitting the job. Okay. So the final output will be collected by the client from where you are submitting the job, right?
So it could be like from the client database or the data lake somewhere, or it could be from the HDFS also, right?
So if you've got a group of cluster, right?
Yeah.
A number of systems, it can be one of it also.
I mean, within the worker nodes, within the
worker nodes also.
Okay. So then, actually, we may not have sufficient memory,
so,
right?
See, what do you mean by the client means?
Client mean the from the end database or the source database.
The machine from where you are submitting it.
Right.
That output for that machine is going to collect the output.
Okay.
That is going to collect the output, right? And in the RAMs, what is present means nothing is present. Now the RAMs are free. Now the RAM is free. Now you can trigger the next flow also. But in this case, now I'll just say one more example. R1, R2, R3 means I want to perform. See, aggregations, right? Sum aggregation, average aggregation, max aggregation, min aggregation. All this you are applying on salary, 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 right? For example, sum of salary, total salary, what is the average salary, max salary, min salary. Means my R3 transformation is extraction of salary. From there onwards, R4 means sum I want to calculate. From there you want to perform something, R5. From R3 again, R6, R7. From there, R8, R9. Means this R3 output used by this flow, this is the first flow. This is the second flow. This is the third flow.
Right. Here data is persisted at R3.
3 flows are there. But 3 flows, first flow, if you want to execute this first flow, flow 1, you will trigger R5 dot action. R5 dot action means first R1 loads, R2 loads, R3 loads, R4 and R5. When R2 ready, R1 removes. When R3 ready, R2 removes. When R4, R3 gets removed. When R5, R4 gets removed. Finally, this R5 also removed. The output collected from that flow 1. If you trigger this flow 1, flow 2, if you want to execute flow 2, see R1, R2, R3, R6, R7, R7 dot action you will say. So from R1, R2, R3, R6, R7. So once they get loaded, the previous one gets removed. Finally, the output is collected. Now what is present? Nothing. Similarly, flow 3 also. But what is your observation here also? R1, R2, R3, R8, R9. So here also everyone, they get loaded and removed, loaded and removed, loaded and removed, output collected. And in all the flows, first 3 steps are common, right? In all these flows, first 3 steps are common or not?
Yes.
Yes, sir.
When you are executing the first flow, okay, why are you re-executing again this first 3 steps again? Already you have executed here, right? Means here you are unable to use this R3 output and for R6. R6 directly can use R3 output, right?
Right.
Already R1, R2, R3 is there. R3 you computed previously in flow 1. Directly I can use R3 output and compute R6, right? Why again you are computing R1, R2, R3? Already in flow 1, R1, R2, R3, R3 computed. The R3 result directly can use by R6, right? But
because it is removed from memory.
Yeah, it is removed from the memory. It's not available in the memory to get the output of R3 by R6 or R8. If I persist it means, persisting means even though the next RTD processed, it will be still available in the, it won't be removed from the RAM. For example, now you persist, now you see the first flow, R1, R2, R3, R4, R5. When R1, R2 ready, R1 removed. When R3 ready, R2 removed. When R4 ready and processed, R3 will it be removed?
No.
R3 won't be removed, right?
Yes.
When R5 is processed and ready and R4 gets removed, final output collected R5. Now what is available in the RAM? R3 available in the RAM, right? When R3 available in the RAM, flow 2, what it can do? Directly your execution flow will start from R3 is ready to give the output and R6 takes this output of this and as input and computes R3, R6, R7. That's it, right? Only a small flow. We are no need to execute from the starting, right? R3 is available within the RAM to give its output to the next flow. Similarly, in flow 3 also, no need to execute. R3 is available. See, R6 is ready, R3 won't remove. R7 ready, R6 removed. When total output collected, R7 also removed. Now what is present? R3 present. Now when R3 is present, directly I can say R3, directly R3 output we can take and R8 will be computed. R8 and R9. Now once the execution finished, all this will be removed, only R3 will be available. Means here you may ask what advantage you are getting. Here it is a small flow, but if it is a bigger data flow, right? Yes.
So, sir, someone has to design this workflow, right?
R1, R2, yes, I'm coming to that. R50 is there. R50 is output used by R60, R70, R80. First, this flow executed. Your persist, now I'm talking about persist feature and transformation reusing and what is lazy evolutions. These three to make you understand, right? Later, I'll be discussing all this with multiple examples. So here, first flow executed. Second flow, R50 available in the RAM or not? Yes, try to respond. I want the sessions to be interactive, right? So that your answers are correct or wrong, you can keep responding. You can unmute yourself, give your responses through voice or through chat panel. So R50 available, right? R50 available means flow to directly not to need to execute the first 50 steps, directly 50 to R70, 2 steps enough. Because R50
so someone has to make R50 as
persist. Yes.
persist, right? Then only it will be. It will not be removed, no?
So we will be writing. We will be designing those things. Which output is used by multiple flows, you will come to know, right? In all the 3 flows, which output is used by different flows, that you will be persist. So here 50 steps decreased. No need to re-execute again and again. So we are just persisting it. It can be reused. Means here the advantage is reusing feature and persistence feature. Okay. Fine. Okay. So this is just an overview of this RTDS and computations. Next session I'll be discussing in brief, right, with clear notes, with multiple examples, how this computation happens, the other things, right? Just it looks very simple and easy. So even I said why we are using this, someone was asking, right, why Python is preferred. Means Python itself very less coding, simple syntaxes, looks like normal English statements. It has got wide varieties of many built-in libraries or modules, I can say. Using, we don't need to write huge codings. By using them directly, we can perform the operations.